question we are talking about, consider the three planes, which is pi1, pi2, and pi3. And the planes are given, the equation of the planes, and these are in the Cartesian form. Show that the three planes do not intersect. So whenever we need to show that any planes do not intersect, so the one of the method that we could use is, we have to think about solving them simultaneously. Of course, we are going to use this matrix method. For part A, if I use this matrix method, so I need to write down all the coefficients. So that's basically 2 minus 1, 1 for the first row, then 1 minus 2, 3 for the second row, and minus, okay, I'm slightly going to change the order. Just for the row reduction, I need, it will be easier to do the calculation if I have 1 here. So that's why I'm going to write down the plane 2 at the beginning. So it's going to be 1 minus 2, 3. Then we have 5. Then I'm going to write down the plane 2, so which is 2 minus 1, 1, and 4. And minus 9, 3 minus 2. And we will have it as 32. So in that case, so if I'm solving this, so I should be able to find the point of intersection. Let's see. So in order to find the point of intersection, I need to think about making these two numbers as 0. So that's basically row 2 and row 3. So the row 2, I'm going to take it as row 2 has to be equals to row 2 minus 2 times row 1. And for row 3, I'm going to use the row operation, something like row 3 is equals to row 3 plus 9 times row 1. So if I do that, so these two positions will become 0. The first row remains unchanged. And in the second row, so this is going to be 2 minus 2 times 1. So that would be 0. And this one is going to be minus 1 minus 2 times minus 2. So it's going to be minus 1 minus 2 times minus 2. So that's going to be positive 3. And it's going to be 1 minus 2 times 3, which is negative 5. And next one is going to be 4 minus 2 times 5. So that's basically negative 6. For the third row, this part will become 0. Then row 3 plus 9 times this. So that means it's 3 plus 9 times minus 2. So which would be negative 15. Then it's minus 2 plus 9 times 3. So which is basically 25. And finally here, it's 32 plus 9 times 5. So that's basically 32 plus 45. So 32 plus 45 is going to be, I believe, 77. Yes. So now, if I simplify this, now the next thing is I need to think about making this position as 0. But you should not use row 1. If you use row 1, these two positions will become again non-zero numbers. You should always use row 2 to make this position as 0. So that's why row 3 would be equals to row 3 plus 5 times row 1. So when I, 5 times row 2. If I do this, that particular position will become 0. So the first two rows remains unchanged. Okay, and this part will become 0. And this is going to be negative 15 plus 5 times 3. So negative 15 plus 5 times 3 would be 0. And this is going to be 25 plus 5 times negative 5. This part will also become 0. But the other side, we will be having 77 plus 5 times negative 6. So which is nothing but 77 minus 30. So which is nothing but 47. So we are getting something like this. So that means, so from here, if I cannot solve this equation. So suppose Suppose if I get some value here at this position. So suppose if I had 1 or 2 or something, I would have took 2z equals to 47. I would have got some result. And here, basically 0 times z is equals to 47. So that means we are saying that 0 equals to 47. It's not true. 0 is never be equals to 47. So that's why there is no solution exist. So even if you have completely 0 in the last row, that means still there could be a point of intersection. So that still there could be a line of intersection, not the point of intersection. But whenever you have the last row to be, so you have 0 at one side and 47 on the other side, or any other number, basically this one says these two are not the same. So that's why three planes do not intersect. So this is the one of the method that you can use it. And the marks distribution goes something like this. Of course, you can also think about using a different method. You can also solve them simultaneously and check whether you are able to get any values of x, y, z. And this is also like solving the simultaneous equation using the matrix method to get the value of x, y, z. And we were unable to get it. So that's why the three planes do not intersect. And here the 4 marks distribution for the sum would go something like this. So 1 mark is for trying to solve the three equations simultaneously. And the second mark and the third mark is for this one. And the final mark is for showing it with the reason that it doesn't intersect. This is how the 4 marks are distributed for this sum. Next, if I talk about B part 1, show that the point 1 minus 2, 0 lies on both pi 1 and pi 2. So, which is plane 1, we have it, plane 1. So, which is 2x minus y plus z is equals to 4. So, if any point lies on this, so that means in place of x, y, and z, you can substitute it, and both the sides, it must be the same. So, it's going to be 2 times 1 minus of minus 2 plus 0. And when you simplify this, you'll be getting 2 plus 2, which is 4. And 4 equals to 4, so that means it lies. For the plane 2, we have x minus 2y plus 3z equals to 5. So in that case, it's going to be 1 minus of minus 2 times minus 2 plus 3 times 0 equals to 5. And your 1 minus 2 of minus 2, this is going to be 4. 1 plus 4 is 5. So 5 is equals to 5. So this is also true. So that's why we can see that the point 1 minus 2, 0 lies on both the planes. Now for part 2, find the vector equation of a line, the line of intersection of plane 1 and plane 2. Now we need to find the line of intersection. Now, whenever we talk about finding a line of intersection, so you need to know that. So the first of all, we need to find the line of intersection. So whenever we talk about finding a line of intersection for line plane 1 and plane 2, so that is basically you just need to think about solving these two equations simultaneously. But the challenge here is we have only two equations, but three unknown variables. Whenever you have two equations with three unknown variables, you should always take something as t, any one variable as t. So I'm going to take z as t here. So I'm going to take z as t here, and I need to get y and z, y and x completely in terms of t. So in that case, it's going to be 2x minus y plus t equals to 4. And the second equation is going to be x minus 2y plus 3t equals to 5. So the first equation, I'm just going to multiply it with, let's say 2. So that I'm going to solve it by the elimination method. So the first equation can be rewritten as 4x minus 2y plus 2t equals to 8. Now, if I subtract these two equations, so x minus 4x would be minus 3x, then minus 2x minus of minus 2x will become just 0. And 3t minus 2t would be plus t. And 5 minus 8 has to be just minus 3. When t goes to the other side, so it's minus 3x is equals to minus 3 minus t. And when minus 3 goes to the other side, so x is equals to, you can also divide minus 3 to both. So it's going to be just 1 plus t by 3. So I got x as well in terms of t, and z is already in terms of t. So we need to figure out now what is y in terms of t. I'm going to substitute it in this first equation. So I'll take the y to the left hand side, y to the right hand side and 4 to the left hand side. So it's going to be 2x. So x is nothing but 1 plus t by 3 plus z, which is just t. Then 4 comes to the left hand side minus 4. This is what is y is. So in that case, it's going to be 2 plus 2 by 3t plus t minus 4 equals to y. So 2 minus 4 has to be just minus 2. Then it's basically 2 by 3 plus 1 is going to be 5 by 3. Equals to y. Now, this is what is the solution. And this one looks like a parametric equation of a straight line. So whenever I have a parametric equation, so which is in the form of x equals to 1 plus, you can also say it as t times 1 by 3, and y is equals to minus 2 plus t times 5 by 3, and z is equals to, you can also say it as 0 plus t times 1. So whenever you have it like this in the parametric form, you can say the equation of line to be. So we need to find it in the vector form. Equation of L to be equals to. So you can just say it as R, or you can also say it as X, Y, Z. R is equals to position vector would be 1 minus 2, 0 plus T times 1 by 3, 5 by 3, and 1. Now, whenever you have a fraction, you can also take out that fraction common out. So it's going to be 1 minus 2, 0 plus t is anyhow constant. Even if you take 1 by 3 common out, it's t times 1 by 3, which will still be t into 1, 5, 3. And this is the right answer for this sum. And here the marks distribution would go something like this. So 1 mark is for showing that this particular point lies on both the planes. And the second mark is for trying to solve them simultaneously by taking some variable as t. And the third mark is for getting x, y, and z in terms of t. And the fourth mark is for putting the position vector correct. And the fifth mark is for putting the direction vector correct. So this is how overall 5 marks are distributed for part B. Now, if I talk about part C, find the distance between line and plane 3. So now we have line somewhere like this, and we already know the equation of line to be something like 1 minus 2, 0 plus t times we have it as 1, 5, and 3. So this is the equation of line. And now we have a plane. So let's say we have a plane, something like this. Let's say this is what is the plane. Now we need to find the distance between this. And we know this, the line and the plane will not intersect because these two are intersecting. So, and all these three things are not intersecting, right? So suppose if the line and the plane 3 are intersecting, then there could have been a point of, there could have been the point of intersection for part A, but for part A, we did not get any point of intersection. So that's why here the lines will not intersect. And one more point you need to understand is, when does the line and the plane will not intersect? The line and the plane will not intersect only when they are parallel. So that means whatever this line we have it, that line is parallel to this. And also whenever we talk about a distance between a plane and a line or distance between any point, so that should be perpendicular to both the line and a plane. So this would be the shortest distance. So we will never do it like, we will never do it something like connecting these two and saying this brown line as the distance. So whenever we talk about the distance between a line and a plane, so it has to be perpendicular. So in that case, you can take any point which lies on the line. I'm going to take the point to be 1, -2, and 0. Now, we have the plane to be something like, the equation of plane is -9x plus 3y minus 2z equals to 32. And here, clearly, if I compare it with the Cartesian equation of a plane, ax plus by plus cz equals to some constant d, your capital A, B, C represents the components of the normal vector. So that means the direction of this normal vector. So this would be the normal vector. So the direction of the normal vector will be equals to -9, 3, and -2. So in that case, if I take this to be, let's say, line M, so the equation of line M would be R is equals to 1 -2, 0. This would be the position vector because this point lies on this line M as well, plus, let's say, lambda into the direction vector is going to be -9, 3, and -2. Now, we know this point on that line also lies on the plane. So that means the point, any point on the line, in general, you can also take it as, when we know the equation of plane, equation of line, we can, in general, we can say it as 1 - 9 lambda will be the x coordinate, and -2 plus 3 lambda would be the y coordinate, and 0 - 2 lambda would be the z coordinate. So in that case, this point is going to lie on the plane. So I can substitute it in place of x, y, z and get the value of lambda. So when I do that, so it's going to be -9 times 1 - 9 lambda plus 3 times -2 plus 3 lambda, then -2 times -2 lambda. And this is what is equals to 32. Now, when I simplify this, it's going to be -9 plus 81 lambda -6 plus 9 lambda, then plus 4 lambda is equals to 32. So when I simplify this, I'll be getting -9 -6. So -9 and -6 has to be -15, and that goes to the other side. So it's going to be 32 plus 15. So which is 47. And your 81 plus this is going to be 94 lambda. So then lambda would be 47 by 94, which is just 1/2. So that means Now we know this, the point which would lie on the plane would be, this point would be with lambda to be, if I take this point as point B and this point as point A, so in that case, we know this point B is going to be 1 minus of 9 times half, comma, minus 2 plus 3 times half, comma, and the last one is going to be, the z coordinate would be minus 2 times half. And if I simplify this, it's B, the point B is going to be 1 minus 9 by 2. So that's going to be minus 7 by 2. And minus 2 plus 3 by 2. So that's going to be just minus 1 by 2. And minus 2 times half is going to be just minus 1. And this is what is point B. And we already know what is point A is, which is 1, comma, minus 2, comma, 0. So we need to find the distance between AB. So that's why the distance is going to be square root of. So we have to use this x2 minus x1 square plus y2 minus y1 square. So that is the formula. So which is nothing but 1 minus of minus 7 by 2 squared plus minus 2 minus of minus half squared plus minus 1 plus 0 squared. If we simplify this, we will be getting the final answer. So this is nothing but square root of 1 minus of minus 7 by 2. So that's going to be 1 plus 7 by 2, which is nothing but 9 over 2. 9 by 2 square. Then here it's going to be plus minus 2 plus half. So that's going to be minus 3 by 2 squared. And here it's just going to be minus 1 squared. So if I simplify this, it's going to be square root of 81 by 4 plus 9 by 4 plus 1. So I can also make it as a common denominator by taking it as a 4. So that's why we will be getting square root of 94 by 4, which we can also write it as square root of 94 divided by square root of 4, which is just 2. And this is the final answer for this sum. And the 6 marks distribution goes something like this. So the 1 mark is for observing that line 1, finding the equation of line 1 with a proper direction. So that observing that the normal vector is minus 9, 3, and minus 2. And the second mark is for finding the equation of line. And the third mark is for substituting the point in the plane. So that's basically this one, substituting the point in the plane. And the fourth mark is for getting the value of lambda. And the fifth mark is for getting the B value. And the final mark is for getting the distance. So basically using this step and finding the final answer. And this is how the 6 marks are distributed for this sum.